Okay, so.
Hello, my name is Molly.
And my name is Josh.
We're going to be talking to you today about how engineers find the best materials for their designs.
So I'm 19 years old and I study chemical engineering at the Ohio State University. And some of the things chemical engineers design range from shampoos, medicines, and foods, and even gas.
And I'm 21 years old, and I'm a biomedical engineer, and biomedical engineers design things such as fake legs, contact lenses, and x-ray machines.
So today we're going to focus on what I did in my lab this summer. And this is where I worked. And this is my workspace. And so I actually did all my work on the computer. And that white little remote control is how I controlled the polymers on the simulation. And this is actually one of the things I created on the computer. It's actually a really big molecule, and I used the remote control to stretch it out. So oftentimes engineers have to choose the materials for their designs. So what kind of materials are water bottles made out of? Plastic, yes. Any other materials?
Aluminum.
Correct. So I brought two water bottles with me today. Plastic one and one out of metal. So why do you think people make water bottles out of plastic?
It's light.
Correct. Also, it's easy to squeeze. So maybe when you're on the go, you can squeeze it. Also, what about metal? Cold, durable. Also, it doesn't melt like plastics do. So if you're in a very hot setting, it won't melt. And yeah, durable.
So just to talk about a few other materials, does anyone know what this is?
Milk.
Milk jug, right. So what is a milk jug made out of?
Plastic.
Plastic, right. Why do you think it's made out of plastic?
Cheating.
Yes, so cheap, I hear.
Squeeze the milk out like the water bottle.
You can squeeze the milk out like with the water bottle, right? So why don't you think this milk carton is made out of metal? Too expensive? That's a good one. Heavy, that's another good one.
So what is this, guys?
Roller coaster.
Correct. And so what do you think it's made out of?
Metal.
Yes, and why do you think it's made out of metal?
Strong.
Strong. If we made, what would happen if we made this out of plastic?
Like break.
Break, and then you'd fall, and this wouldn't be good.
All right, what's this? Parents probably drink it, coffee, right? And so it's a coffee cup. What's it made out of? Ceramic, yeah. And why do you think it's made out of a ceramic material, that hard material? It holds in heat, yeah.
Strong.
It's strong, excellent.
So this is kind of a tough one. What do you think? First off, what is this?
Vest.
Bulletproof vest, correct. So what do you think it's made out of?
Plastic.
Plastic. But so how does it compare to something like this?
Stronger.
Stronger, exactly. So they actually make this in a factory and they put it through a process to make it really strong so that when a bullet hits you, it won't hurt you.
All right, last one. What's this? Not the trees, but this.
Road.
It's a road, right? And what is a road made out of?
Asphalt.
Yeah, it's concrete, asphalt, it's cement. So it's definitely not something that we want to make out of plastic, right? Or not something we want to make out of metal. So as you can see, engineers have to choose materials for their designs. Not only do they have to design the shape of this so that it has a nice handle and you can carry it, but you also have to choose what material it's made from.
So today I'm going to talk to you guys about polymers. I'm going to teach you what they are. So this plastic is actually made from a class of materials called polymers. And so what polymers are, they're made out of really tiny units called MERS. And these MERS are molecules. And so what happens is they connect to each other, like this. And when they connect, they form polymer. And when they get big and bigger and bigger, their properties change, and they become stronger and stretchier.
So how small is a MERS? To give you guys an idea of what we're talking about when we say that it's small molecules. So you can see that this is the size of a human, and if we zoom in further, we get the size of a basketball, we get a penny, size of an ant, and if we keep zooming in, we get bacteria, the size of a hair, a cell, and we keep zooming all the way in past what you can see with just your eyes, and you need a microscope or something like that to see this, and this is about the size of what a mer is. So all of those mers come together, and lots of them together make a polymer. So if we zoom out to give you an idea of how small these things are, we can zoom out all the way out
To outer space
to
and
outer
beyond.
space.
So today we're going to be creating parachutes. And so what do you think parachutes are made out of?
Material.
Plastics. In fact, they're made out of polymers because polymers are plastics, right? And so what kind of qualities make a good parachute? Strong. Doesn't tear. The other ones? Lightweight. Yeah.
Stretch a little.
Yeah, you
Yeah.
can stretch it, it can be packed up.
That's
one?
advanced.
So this is a list that we came up with, and you guys pretty much got most of them. But also a lot of times you have to be able to fold them up and put them in a backpack or some sort of pack. And so that's another quality about polymers is that they can fold and then retain their shape once you unfold them.
So your goal today is to get Mr. Lego, which I have in my hand right now, to land safely from the ground. And the rules are that you must design and test a parachute. The parachute must fit into Mr. Lego's backpack. And the parachute must not break. But just like real engineers, before we actually drop Mr. Lego and see if the parachute works, we need to test it first to make sure that Mr. Lego is going to make it safely to the ground. So we have this setup in which there's a block and a strain gauge. So the strain gauge is this blue squiggly line, and the strain gauge is going to be measuring how much force or how much power the parachute can take. So when we blow on the parachute, the gauge is going to stretch out and the parachute's going to hold air. And you have to see how strong you can make that parachute so that it holds as much air as possible without breaking.
So today we brought in our own parachute that we made. Does everybody see it right here? Yeah, so you guys are actually making this model. And so we have a few rules and instructions for you guys. So the materials you're going to receive are a piece of aluminum foil, and you're going to put holes in each corner. And then you have these strings right here, and you're going to thread the strings through the holes, and then tie the aluminum foil, and then you're going to tie 2 of the strings to each arm, Mr. Lego's arm. And that's pretty much the prototype. And so you guys are going to make this, and then you guys are going to make your own, and then test it, similar to what Molly just showed you.
You guys have any questions? Yes, Nate.
Do I get to keep the parachute?
Yes, you can keep the parachute and safely deliver Mr. Lego to the ground for the rest of your life. Yes. No, you do not get to keep Mr. Lego. Any other questions? Yes.
Does each group get a Lego, or is it just one at a time?
Each group gets a Lego. Man.
Any other questions?
Are all molecules MERS?
Not every molecule is a MER because only certain molecules will connect to each other to form polymer. So it depends on the molecule. Any other questions?
How do I know if my designs fail? Passed or passed? How do I know if my design's passed?
So when you blow the parachute with the fan or whatever, then if it breaks or tears, that means your parachute's not strong enough. And so that's one way it fails.
How strong is a passing design?
A passing design will withstand the top power that the vacuum does for 30 seconds.
Okay.
Okay, any other questions? All right.
Please
let's
give him
get
a round of
started.
applause.